Hello students, welcome back to today's video class. In the last video class we have completed up to the characteristics of chemical reactions and the types of chemical reactions we have completed. In today's video class I am going to start the reactivity series. What is a reactivity series? Reactivity series is also called metal reactivity series. This series is the arrangement of metals in the decreasing order of their reactivity. Okay. So you can see, just a minute. You can see here I have just written the reactivity series of the metals. From it is potassium, calcium, sodium, magnesium, aluminium, zinc, iron, nickel, then tin, lead, hydrogen, copper, then mercury, silver, gold, and last platinum. Sometimes platinum is not given in the book, but the least reactive metal is platinum. If we see the metal activity series, first three elements, that are sodium, potassium, calcium, and sodium, these are called most reactive. These are most reactive metals. Okay. After that, magnesium to lead. Magnesium to lead. This part of is called metal that reacts with generally acid. Metals reacts with acid here. Okay. Reactive, they react with most reactive metals and reacts with water. Okay, these metals generally react with acid, not water. After that, hydrogen, though it is a non-metal, but for comparison basis, we have to keep the hydrogen in the metal activity series. But below the hydrogen, you can see that from copper to platinum, these metals are least reactive metals or unreactive metals. These are called least reactive metals. These are least reactive metals after hydrogen. So this is the metal activity series. Now we will see the some features of this metal activity series. If you see the metal activity series, from the first that I have written, they are most reactive metals, and they generally react vigorously with water very quickly. That's why you know that sodium, potassium, we keep it in the kerosene oil. After that, you can see from magnesium, aluminium, zinc, iron, nickel, tin, lead. These 7 elements are reactive series are displaced. They have reactivity with mainly acids. Okay, and the first three metals above the metals which are above the hydrogen, generally they have a tendency to always displace the least reactive metals from a compound. Okay, that we have already seen in the in case of displacement reactions, that I will show you few examples today also. After that, you can see the copper, mercury, silver, argon, gold, and platinum. These are the least reactive metals. They does not react vigorously with oil, water, moisture, or any oxygen, etc. So they are the least reactive metals. After that, why hydrogen is kept in the placed in the metal activity series? Very important. Hydrogen is not a metal, but it is already placed because often some comparisons because of some comparisons. Okay, because it has a tendency to gain electron sometime, and it has a tendency to lose electron also. So sometimes it's behave like a metal, sometimes it behaves like a non-metal also, but we cannot place in a metalloid it also. So we have to keep it in a metal activity series due to its reactivity with oxygen mainly. Now, just now I told you that the most reactive metals generally displaces the least reactive metals. Some few examples I will show you here that shows that how most reactive metals are able to displace the least reactive metals. Suppose if I take zinc plus copper sulfate CuSO4. When zinc reacts, you can see zinc is more reactive than the copper. It is above the copper. So zinc will react with sulfate to displace copper. So it will become ZnSO4 plus Cu. So this is the reaction you can see, and this reaction is also called displacement reaction that I have discussed in the displacement reaction in the last video class. Okay, some more example you can see. Suppose if I take magnesium with again CuSO4, so again you can see magnesium comes before copper, so again magnesium will react with sulfate to become magnesium sulfate plus it will give copper. Another example with zinc and H2SO4. So what happened? Again zinc is more reactive than hydrogen, it places above the hydrogen. So zinc will displace hydrogen and react with sulfate to form ZnSO4 plus H2 gas. So this is another example of displacement reaction. So you can see here how the more reactive metals displaces least reactive metals from their compounds and become a new compound. Okay. After this, the formation oxides and their classification. After the discussion of metal activity, we will move to the another part section of the chapter. That is oxides and their classification. Oxides and their classification. Okay. So actually oxides can be divided into what are oxides? Mainly when metals or non-metals react with oxygen, they form metallic oxides or non-metallic oxides. So on the basis of reaction with elements with oxygen, the oxides are classified into two groups, that is called mainly four groups, sorry. One by one we will see. First one is the acidic oxide, then the basic oxide, and third one is the amphoteric oxide, and last one is the neutral oxide. What are acidic oxide, basic oxide, amphoteric oxide and neutral oxides? If we discuss say about the acidic oxide, when non-metals with oxygen, it gives an acidic oxide. For example, if I take an example of carbon plus O2, it gives CO2. Okay. So why it is called acidic? Because when this carbon will react with water, it will carbonic acid H2CO3. So this is the acidic in nature. So these compounds are called when non-metals reacts with oxygen, it gives non-metallic oxide. When further non-metallic oxide reacts with water, it gives an acid. So this is called, that's why these oxides are called acidic oxide. Another example you can take, suppose sulfur with oxygen, it gives sulfur dioxide or sulfur trioxide. When they react with water, it will give sulfuric acid, like that. So you can give, which example is given in your book also. Next is the basic oxide. What are basic oxides? Here metals reacts with oxygen. Here metals reacts with oxygen to give metallic oxide. Suppose calcium plus O2 gives calcium oxide. Okay. So when calcium oxide with further reacts with water, it gives calcium hydroxide. Okay. It will give calcium hydroxide. So when CaO plus H2O, it reacts with CaOH, and calcium hydroxide is basic in nature. It is basic in nature since hydroxide ion is present, so it is basic in nature. So this is the way we can see when metals react with oxygen, they gives out metallic oxide. When further metallic oxide reacts with water, it gives a base. So that's why it is called basic oxide. After that, next is the amphoteric oxide. What are amphoteric oxide? Amphoteric oxide means oxide with oxides of some metal which have shows the properties of both acid and bases. Shows both the properties of acid and bases. For example, it shows both properties of acidic and basic. It shows both acidic and basic in nature. It shows, for example, if I take you can Al2O3 means it is dialuminium trioxide. It is dialuminium trioxide is an example of amphoteric oxide. Another example you can take because when this aluminum trioxide Al2O3 reacts with NaOH means sodium hydroxide, it will give you sodium aluminate NaAlO2 plus H2. It will give you sodium aluminate. Okay, so this is the sodium aluminate is the so sodium aluminate you will get. So amphoteric oxide this produces sodium aluminate. When the further this same sodium oxide aluminum dialuminium trioxide react with an acid, when it will react with an acid, because you can see it, since it is reacts with here base, sodium hydroxide is a base. Again, if you take the reaction of Al2O3 with an acid, suppose H2SO4, what you will get? You will get aluminium sulfate. You will get aluminium Al2SO4 whole 3 plus water. Okay, plus water. So aluminum dialuminium trioxide is amphoteric in nature because it reacts with both base and the acid and give the compounds. Okay, and with water. That's why this type of compounds are called amphoteric oxides. Okay. Next is the neutral oxide. What are neutral oxide? Neutral means, you know, they have do not show any they neither show neither acidic nor basic properties. So it will be neither shows acidic or basic properties. Okay. So for example, carbon monoxide, CO, carbon monoxide is an example of neutral oxide. After that, you can have nitrogen oxide, NO. Nitric oxide. It is not nitrogen oxide. It is nitric oxide. And another example that you can nitrous oxide, N2O. It is nitrous oxides. All these are the examples of some neutral oxides. Okay, so we have seen how the metals and non-metals reacts with oxygen, and they give the different types of compounds. When metals reacts with oxygen, it gives basic oxides. When non-metals reacts with oxygen, it gives acidic oxides. Because when this reacts with water, the basic oxides reacts with water to form the bases, and when acidic oxides reacts with water, it gives the acids. And of compounds, it shows both the property where both reacts with both acids and base. That type of oxides are called amphoteric oxides. For example, dialuminum trioxide. And next is the neutral oxide. Neutral oxide means the oxides which doesn't neither reacts with acid or bases. Those they shows the neutral characteristics. For example, carbon monoxide, nitrogen oxide, the nitric oxide, and then the nitrous oxides. Okay, so these are the few things which I have discussed today. So still the chapter is left with us, but we have no time to continue this chapter today. No, we have 3 minutes left with us to discuss with this. The next is the formation of oxide of metals from their ores. So this is another continuation of this chapter. So forming oxides of metal from their ores. What are ores? First of all, you should know what are ores. Ores are the minerals from which we get the metals or non-metals, mainly metals, economically and easily. That are called ores. From ores, the ores are we can get the metals by so many processes. To discuss with the processes, it is given in your book. That is, suppose iron, aluminium, copper, zinc. They are not available in the earth crust free in state. They are extracted from their ores, which may be in the form of various compounds and such carbonates and sulfide. These compounds may be carbonates or sulfide. It more convenient to extract the metals. I just now said that from ores we will get the metals more conveniently and economically than that minerals will be called as ores. So hence the available ores is the first converted to their respective oxides. After respective oxides, the two ways of forming the ores into their respective oxides. What are the two processes? First one is the calcination. First one is the calcination. What is calcination? Calcination is the decomposition of reaction in which metals are heated. Calcination decomposition reaction where metals are heated strongly in limited supply of air. Here, heated strongly in limited supply of air. Limited supply of air. Okay, so it should be metals ores will be heated strongly in the limited of supply of air, then it is called an calcination, and we will get a metallic oxide. For example, if you get most of the time this process can be followed for the carbonates of zinc, then magnesium and copper. So carbonate types of ores are generally made to form their oxides by the process of calcination. Okay, so what we will give, give some examples. Suppose ZnCO3, when it is heated strongly in the limited supply of air, it will decomposes to form ZnO plus CO2. Carbon dioxide will be liberated and you will get the zinc oxide. Okay, from this zinc oxide you can displace the oxygen with the reactions of some reducing agent. Zn plus, suppose hydrogen, it will give Zn plus H2O, or some other reducing agent we can use. Suppose carbon is a good reducing agent, like that. After that, another example is Mg. It's MgCO3, again magnesium carbonate. When it is heated, again when it is heated strongly, you will get MgO plus CO2 again. So we can see here how these things are from magnesium. Their pores on heating strongly in limited supply of air, we will get the metal oxides, and from these metal oxides we can get the pure form of metal by reacting them with some reducing agent to displace oxygen. Okay, so this is the calcination process. Another process is the roasting process. Roasting. What is roasting? It is a roasting process. What is roasting? In this, it is just opposite of the calcination process. Roasting is the process in which ores are heated strongly, but in the presence of air. Again heated strongly. Here also ores are heated strongly in presence of air. So what type of ores are strongly heated in the presence of air? Mainly here sulfide ores are used. Here mainly sulfide ores are generally made into their oxide forms by the process of roasting. And in the process of roasting, what we do, we have to strongly heat the ore in the presence of oxygen. Okay, so we can see after and this process is conducted in a special type of furnace, and that furnace is called reverberatory furnace. This furnace is called reverberatory furnace. So how these sulfide ores are heated in the supply of oxygen? So we will get ZnS, zinc sulfide, plus oxygen. What you will get? You will get ZnO, means zinc oxide, plus sulfur dioxide gas. So sulfur dioxide gas will be liberated from it. So another example, if I take FeS, iron sulfide with oxygen, you will get FeO, you will get FeO ferrous oxide plus again sulfur dioxide. Okay, so these are now you have these are all unbalanced equation I have written, so you have to balance them again. So this is the process by which we can see how the ores can be oxidized in the two processes. First one is the calcination process, next is the roasting process. Both the process ores are strongly heated, but in the calcination process we use the limited supply of air, and in the process of roasting we need a proper supply of air. Okay, in calcination process mainly carbonate type of ores are used, and in the roasting process mainly we use the sulfide ores to get metal oxides. Okay, and this roasting process is done in the special type of furnace that is called reverberated furnace. Okay, so this is all about the chapter number 6. Since we have today we have completed this chapter. Okay, I hope you have all understand this chapter number 6. So in the next video class we will continue with our new chapter, and we may discuss with the question answer of this exercise also. Let's see what can I do for you, because in the next chapter which we are having, that we have to start, that is the hydrogen. After the carbonate compound, 3 more chapters are left with us. So we have completed chapter number 5 and 6, and still 3 chapters are remain. We have to complete it by January. Okay, thank you. I hope you have enjoyed this class. Thank you.